So good evening all, welcome to SAKALAVIDYA YouTube channel. Okay, in the last session actually we have completed up to 85 problems, but also the just half of the part of the 85 problem have been completed, yet to be completed. So I will discuss that problem. So that's why only this is binomial theorem part 10 only. Binomial theorem part 10. Okay, we'll continue. Today we will try to complete this chapter, and tomorrow onwards we start areas as well as the chapter name is actually I have forgotten, that is conic section. Okay, I hope everybody is joining. Mohamedala Ramesh, Pranav, Siddhartha, Swati, Balu, Cute. Okay, hi. Binomial theorem. Part 10a. Okay. So this is the question 85. 1 plus 1 by 4 plus 1 into 4 by 4 into 8 plus 1 into 4 into 7 upon 4 into 8 into 12 plus dash dash infinity we need to find out. So this we can write, let us say this value equal to sum equal to s, 1 plus 1 by 4 plus 1 into 4 by 4 into 8 plus 1 into 4 into 7 by 4 into 8 into 12 dash dash infinity. So this can be put like this form: 1 plus 1 by 1 factorial into 1 by 4 plus 1 into 4 by 2 factorial of 1 by 4 whole square plus 1 into 4 into 7 by 3 factorial. You can easily expect this is 1 by 4 whole cube and plus so on infinity we can write. Am I correct now? Comparing with 1 minus x raised to minus p by q. This equals to 1 plus p upon 1 factorial of x by q plus p times p plus q upon 2 factorial x by q whole square and so on dash dash infinity. So on comparison we get, see this p value equal to 1, p plus q equal to 4 and x by q equals to 1 by 4. So write down now here, p value is equal to 1, p plus q equals to 4. So obviously q becomes 3 and x by q means x by 3 equal to 1 by 4, x equals to 3 by 4. Now we need to find out s value. This s value is equal to 1 minus x whole to the power of minus p by q. S is equal to 1 minus x, that means 1 minus 3 by 4 whole to the power of minus p by q minus 1 by 3. This is actually we can write 1 by 4 whole to the power of minus 1 by 3. This we can write 4 to the power of 1 by 3, because 1 by 4 is nothing but 4 to the power of minus 1, minus into minus plus. So fourth option is the right option. I hope everybody understood this problem now. Next, let us move to the Aki, right, Ajay Khanna. 86th problem. 86th. If z is equal to 1 upon 3 plus 1 times 3 upon 3 times 6 plus 1 times 3 times 5 upon 3 times 6 times 9 plus so on dash dash infinity. Then first option, z square minus 2z plus 2 equals to 0. Second, z square minus 2z minus 2 equals to 0. Third option, z square plus 2z minus 2 equals to 0. Fourth one, z square plus 2z plus 2 equals to 0. This is the problem. Okay, Sanjay, welcome. First you need to subscribe. Z equals to 1 upon 3 plus 1 times 3 upon 3 times 6 plus 1 times 3 3 times 5 upon 3 times 6 times 9 plus dash dash infinity. So first write down like this solution. Z equals to, we can write 1 by 1 factorial upon 1 by 3 plus this we can write 1 times 3 by 2 factorial into 1 by 3 whole square, write down dash dash infinity. It is incomplete series. 1 is not there. First term is not there. Add first term. 1 plus z, 1 plus write down. Comparing with 1 minus x whole to the power of minus p by q, whose value is equal to 1 plus 1 by 1 factorial of x by q p times p plus q upon 2 factorial x by q whole square plus dash dash infinity. So by comparison, okay, Ishik Vardhan Reddy, where are you from? So now we get here p value is equal to 1, am I correct? P plus q is equal to 3. That implies q, obviously q is equal to 2, whereas 1 plus z equals to 1 minus x whole to the power of minus p by q. So 1 minus x, here 1 minus x means we need to find out x by q is equal to how much? X by 2 equals to 1 by 3, x equal to 2 by 3. This is 1 minus 2 by 3 whole to the power of minus 1 by 2. This will be 1 by 3 whole to the power of minus 1 by 2, that will be root 3. 1 plus z is equal to. So that means now 1 plus z is equal to root 3. Squaring on both sides. We get 1 plus z whole square, z square plus 2z plus 1 equals to 3. Therefore this can be further simplified. Z square plus 2z minus 2 equals to 0. That means third option is the right option. Third option is the right option. Okay, right. Okay, next problem. Bhavana Gayatri, make a call to me personally, I will discuss with you. Okay. 87. The number of terms okay, no problem. The number of terms in the expansion of a plus 4b whole cube plus a minus 4b whole cube raised to 2 is, first option is 6, second option 8, third option is 7, fourth option is 3. Okay. The number of terms in the expansion a plus 4b whole cube plus a minus 4b whole cube raised to 2. We need to find out. So first let us find out this a plus b 4b whole cube plus a minus 4b whole cube. General, for example, only if you consider a plus 4b whole cube, there are 4 terms. So if you add these two, you will be getting like this 2 times. Whenever we add odd terms, you will be getting actually 2 times t1 plus next t2, t3, okay, t3, third term. So next only 4 terms, 2 terms you will be getting. That means you can say 2t1 is equal to, you can say x, 2t3 is y. Now the expansion becomes becomes like this form, x plus y whole square. Therefore number of terms is equal to this is a binomial, being it's a binomial, n plus 1, that is 2 plus 1, we get 3 terms. That means fourth option is the right option. 88. Question number 88. Right. Varun Bittu. Okay, Suma is there, Sudha is there, Ishwarappa, Rakshita, Chand Basha, Vaishnavi, Nosamalla, Mahesh. Okay. The number of terms in the expansion of a plus 4b whole cube times a minus 4b whole cube raised to square is raised to 2. Don't say square, sorry, raised to 2 or whole square. First option is 6, second option is 7, third option is 8, fourth option is 32. How we take the terms means actually x plus a whole to the power of n plus x minus a whole to the power of n is equal to 2 times t1 plus t3 plus t5 plus, because power 3 means only 4 terms. Out of 4 terms, 2 terms are odd, t1, t2, only you get 2 terms only. This is a binomial, it becomes binomial. So that will be in the form of x plus y whole square. So the number of terms in the binomial is equal to power plus 1, index plus 1. Index is 2, 2 plus 1 is 3. The number of terms in the expansion a plus 4b whole cube times a minus 4b whole cube times raised to 2. First let us simplify. Okay, you are from Andhra Pradesh, Kirtana. Right. Solution a plus 4b whole cube and a minus 4b whole cube. So we have basic formula algebra a to the power of m into a to the power of n. This we can write b to the power of n, a to the power of n into b to the power of n, ab to the power of n, a multiplied by b whole to the power of n we can write. This using a plus 4b times a minus 4b whole cube and raised to power is 2 here. This is a plus b into a minus b. This we can write a square minus 16b square whole to the power of 3 into 2 is 6 you can write. It's a binomial. It's a binomial. That is different. Yes, n plus 1 by 2. So a square minus 16b square whole to the power of 6. Therefore number of terms is equal to, being a binomial, n plus 1. Here n is 6. 6 plus 1 is we get 7 terms. Second option is the right option. Eighty-nine. Question number 89. The number of rational terms. The number of rational terms in the expansion of 1 plus root 2 plus cube root 3 raised to 6 is, first option is 6, second option is 7, third option is 3, fourth option is 8. Number of rational terms in the expansion of 1 plus root 2 plus cube root 3 whole to the power of 6 is. This is very important problem. So important problem. You need to check it now. Right. Now the solution. This 1 plus root 2 plus root cube root 3 whole to the power of 6. This can be written 1 plus 2 to the power of 1 by 2 plus 3 to the power of 1 by 3 whole to the power of 6. So now we need to discuss multinomial theorem. Multinomial theorem. I already changed Pramila. I have seen everything. Because next time onwards I won't open. I decided. That's clear. So now the multinomial theorem. So multinomial theorem means x1 plus x2, say like this, some x3 and so on dash dash plus xn or xp whole to the power of something n. General term is equal to, in this one, general term general term is equal to, we can write like this, n factorial by n factorial by, say this is, so we can write in this one, for example, this power is, you can say, this power is alpha factorial and beta factorial and gamma factorial and so on dash dash. See, x1 to the power of alpha and x2 to the power of beta and so on, xp to the power of something, say alpha 1, otherwise alpha 2, alpha p. This is alpha 1 factorial, alpha 2 factorial and alpha 3 factorial, where alpha 1 plus alpha 2 plus so on dash dash, this alpha p must be equal to index of the multinomial equal to n. This is the multinomial theorem. So using multinomial theorem, here general term write down, general term, say like this, 6 factorial by, here 3 terms we have, their powers you can take like this, alpha factorial, beta factorial, gamma factorial, 1 to the power of alpha, 2 to the power of 1 by 2, 1 to the power of beta, beta by 2 multiplied by, and next 3 to the power of gamma by 3, where alpha plus beta plus gamma must be equal to 6. Now we need to select alpha, beta, gamma whose value is equal to 6 such that it should be rational terms. It should be rational means, you remember one thing, beta must be multiple of 2 because beta should be divisible by 2. Gamma is the multiple of 3. We need to select like that, different combinations and whose sum is equal to 6. Then we get the number of rational terms by giving different values to the alpha, beta, gamma is equal to 6 such that alpha may be any real number except 0, but alpha may be 0 also, no problem. So beta is the multiple of 2, gamma is the multiple of 3. Let us see the combinations now. Let us see the combinations. 89 solution. You take like this, alpha, beta, gamma, such that you need to check this one, alpha plus beta plus gamma must be 6. So one combination I will take like this, 6, because gamma should be multiple of 3. 6 is divisible by 3. 0, 0. 0 plus 0 plus 6, 6. Okay, one combination we get it. That means one term you will get it. And the next combination you take like this, 0, 6, 0. 6 is a multiple of 2. This is other combination you will get it. So next 6, 0, 0. So next combination is 1, 2, 3. Okay. 1 plus 2, 3, 3 plus 3, 6. Next combination we can take 2, 4, 0. Okay, next combination we can take 3, 0, 3. Next combination we can take 4, 2, 0. Now count them. How many such terms we shall get it now? This is 1, 2, 3, 4, 5, 6, 7, you will get it. Therefore, number of rational terms is equal to 7 is the answer. 7 is the answer. Okay. Am I audible to you? Am I audible to you? Am I audible to you? Right. Second option. Thank you, thank you. 90. 9 to the power of 11 plus 11 to the power of 9 is divisible by first option 7, second option 8, third option 9, fourth option 10. Right. Now 9 to the power of 11, 9 can be written 10 minus 1, am I correct? 11 to the power of 9, 11 can be written 10 plus 1. See solution. This 9 to the power of 11 plus 11 to the power of 9 can be written 10 minus 1 raised to 11 plus 10 plus 1 raised to 9. Let us expand it. So using the binomial theorem. Okay. Right. I will come to the problem. Don't worry. Don't worry. Don't worry. Okay. Kalyani, shall I make a move? Then better you take a screenshot. After that you can have the glance over that one. Right. So now 9 to the power of 11 plus 11 to the power of 9. 10 minus 1 all to the power of 11 plus 10 plus 1 all to the power of 9. Using binomial theorem. So both powers are indices are different. So we need to write individual itself only. Right. 10 to the power of 11, first one, plus 11 C 11, 10 to the power of 10. This sorry, absolutely sorry, because minus is there. You get minus. I am so sorry. 11 C2, 10 to the power of 11 minus 2 is 9, and plus dash dash you will be getting minus 1, and minus of 10 to the power of 9 plus 9C1, 10 to the power of 8 plus 9C2, 10 to the power of 7 plus dash dash plus 1. This will be. Okay. Because this 1 to the power of 11 will be odd, you will be getting minus sign. So brackets, now remove the brackets. Now what do you get now here? Okay, right, let us check. 11C2 minus 11C3 plus 11C4 minus 11C5. Okay, this will be 11C11. Right, absolutely correct. Right. Right, now this will be 10 to the power of 11 minus 11C1 10 to the power of 10 plus 11C2 10 to the power of 9 plus dash dash. Okay, this will be 10 to the power of 9 and dash 11C 10 bracket and minus, this will be 10 to the power of 9 plus 9C1 10 to the power of 8 plus 9C2 10 to the power of 7. This will be 10 to the power of, okay, plus 1, write down, this is plus 1, right, plus dash dash 11c 10, okay, right, don't write this sign now, minus 1, this will be minus 2, you will be getting. Here what can you take common now? You can take 10 common, you can take 10 to the power of, yes, 10 common. Here you can take 10 common. If you take 10 common, this will be like this. You can write like this. If you take 10 common, you can say 10p, minus 10 common, you get 10q, and minus 2 write down. This will be again 10 common, 10 of p minus q minus 2. Say p minus q is equal to k, 10k minus 2. So now you do one thing, 10k plus 10 write down, and minus 10 write down, and 10 minus 2, 8 write down. This will be 10 common, once again 10k plus 8 you will get it now. So as it is in the form of 10k plus 8, if you divide by 10, remainder is 8. So answer is 2. Second option is the right option. So in 10th class you might have studied Euclid division algorithm. Euclid division algorithm means, what is the Euclid division algorithm? Suppose if you write AB is equal to AQ plus R, if you divide this AQ plus R by B, the R will be the remainder. Understood now? So that means actually 10k plus 9 is divisible by here 8. So that means divisible by 8. So this is the answer. Now if you divide by 10, what is the remainder? You will get it now, 8. Option 2. What is the question number? 91. The coefficient of x to the power of 9 in the expansion of x minus 1, x minus 4, x minus 9, and so on dash dash x minus 100 is the coefficient of x to the power of 9, in the expansion of x minus 1, x minus 4, x minus 9, and so on x minus 100 is. First option is minus 325, second option 365, third option 425, fourth option is minus 385. Okay, so now your solution, this we can write x minus 1 square write down, 4 can be written x minus 2 square write down, 9 can be written x minus 3 square write down, and so on dash dash x minus 10 square write down. That means here we have 10 terms. In this bracket we have 10 terms. 1, 2, 3 up to 10 terms. So 10 terms means if you multiply the 10 brackets, highest degree will be, degree of this one will be, degree is equal to x to the power of 10 you will be getting. Highest power is x into x into x into 10 times x to the power of 10. So right, thank you. Right. Okay. Degree is actually 10. Degree 10 means we need again x to the power of 9. X to the power of 9 coefficient is equal to coefficient of x to the power of 9 equals to, we can write the minus of 1 square plus 2 square plus 3 square and so on dash dash 10 square. So this is nothing but minus sigma of n square from n is equal to 1 to 10. So we have the formula for sigma n square. The sum of the squares of the first n terms. Okay. Sigma n square is equal to n into n plus 1 to n plus 1 upon 6. Okay. Here n value is 10. You can write minus 10 times 11 times 10 into 2 20. 21 upon 6. Now 3 2 ja, 3 7 ja, 2 5 ja. So minus 55 into 7. That is equal to 35, 385, but minus. So fourth option is the right option. Fourth option is the right option. Now 92. 92. 92 question. If n is an integer, lying between 0 and 21. 0 and 21. Then the least value of n factorial times 21 minus n factorial is, I want to note 91. Okay, I will discuss 91. Okay, 91. Right. Okay. Have you noted down? Thank you. Let's move to the 92. Shall I make a move? Right, 92. N is an integer lying between 0 and 21. Right. The least value of n factorial and 21 minus n factorial we need to find out. So that means, you see, remember one thing. Let us say okay, solution now. Let us discuss solution. To get least value of n factorial into 21 minus n factorial. Okay. First options, let me discuss. 1 factorial into 20 factorial. Second is 11 factorial, 10 factorial. Third is 9 factorial times 12 factorial. Fourth option is 2 factorial and 9 factorial. Okay. Now, Prithvi Bejawada, thank you. You have given good comments. Right, keep it up. And others also, other two. Okay. So now to get the least value of n factorial and 21 minus n factorial, see this 21 factorial upon n factorial into 21 minus n factorial should be maximum, greatest, maximum. See, it seems to be rather in this form, n factorial by r factorial into n minus r factorial, whose value is nothing but NCR, formula for NCR. So that means this can be written, that implies this we can write 21 Cn should be maximum. It is maximum yet n is equal to 21 plus 1 by 2, that is 11. That means yet n is equal to 11, it will be minimum. So put n is equal to 11 in this one, you get the minimum value. Therefore minimum of n factorial into 21 minus n factorial is equals to 11 factorial into 21 minus 11, 10 factorial. That means second option is the right option. Right, thank you. Okay. Ninety-three. Right. For Suma also given, Swati, next others too, Balu, Dishwank, for n belongs to n, Kalyani, 1 plus x whole to the power of n. Today evening I will see all your feedbacks. So minus nx minus 1 is divisible by first option 2, second option x, third option is x square, fourth option is x cube. Right. For n belongs to n, 1 plus x whole to the power of n minus nx minus 1 is divisible by. So let the 1 plus x whole to the power of n be expanded and nx minus 1 gets cancelled. Take out something common. Whatever it is common, that will be divisible by the common factor itself only. Today I am delay. Don't worry. What's your name? For n belongs to n, 1 plus x whole to the power of n minus nx minus 1 is divisible by. So now see the solution. This 1 plus x whole to the power of n, we can write 1 plus nc1x plus nc2x square plus nc3x cube plus so on dash ncn x to the power of n and minus nx minus 1. This equal to nc1 is nothing but n, 1 plus nx plus nc2x square plus nc3x cube plus ncn means 1 x to the power of n minus nx and minus 1. Okay, Pramila, in comment box, you ask others, they will guide you. Swati, guide her. Pramila. 1 gets cancelled and nx gets cancelled. From this one we can take x square common out. If you take x square common out, we get nc2 plus nc2x plus so on dash dash x to the power of n minus 2. Actually it is a multiple of x square, therefore divisible by x square. Divisible by x square. Third option is the right option. Third option is the right option. Okay, divisible by x also, but exactly divisible by x square. Comment box only, below description you will find. 94 okay. Ambarish, after a long time, if this bracket x denotes the fractional part of x and n belongs to n, then 5 to the power of 2n upon 24 fractional part is, first option is 0, second option is 1 by 5, third option is 5 upon 25 by 4, fourth option is 1 upon 24. So that means fractional part of this one we need to find out. Okay. Right now, so here put n is equal to 2, no problem, you can substitute. Then becomes 5 to the power of 2n fractional part of 24. When n is equal to 2, it becomes 5 to the power of 2 into 2, 5 to the power of 4. 5 to the power of 4 is 625 upon 24. Fractional part. Divide 625 by 24. 24 3 ja 72. 48. You will be getting 5 4 145. Okay, now let us try with 6. 6 4 ja 24. It's 144. 1. This can be written actually fractional part of 26 plus 1 by 24. See, in this one fractional part we need to write it. Fractional part. Fractional part means actually here, see, this is the decimal, this is the integral part, this will be the fractional part, equal to 1 by 24. So fourth option is the right option. Sir, why only n is equal to? You can take n is equal to any value. You take 1 also, no problem. 1 also, no problem. N is equal to 1, 2, 3, 4, anything you can take it. N belongs to n. Understood now? So in the previous problem also, you can take n is equal to 2 like this also. You will get the answer. Understood now? Next 95. 95. 95. If, but I know the long method also, very lengthy method is there, but that takes time. So one of the viewers has given suggestion for the previous problem. Why should we for the previous problem? This problem also we can apply. One upon 1 factorial times 9 factorial plus 1 upon 3 factorial times 7 factorial plus 1 upon 5 factorial times 5 factorial plus 1 upon 7 times factorial 3 times plus 1 upon 9 factorial times 1 factorial equals to 2 power n upon 10 factorial. Then n equals to, then n equals to first option 3, second option 5, third option 7, fourth option 9. So this is the question. So Prithvi, doesn't matter. No Pramila, in comment section itself only. Comment section only. For every video, so you have the comments section. In that comment section, you need to give the only below description. You will find it the comment section. That's all. Okay. So in WhatsApp group, you should not mention it. Don't send. Solution. So you cross multiply this 10 factorial, but each and every term of left hand side is being multiplied by 10 factorial, so that we can write 10 factorial upon 1 factorial and 9 factorial. This can be written 10 factorial upon 3 factorial times 7 factorial plus 10 factorial times upon 5 factorial 5 factorial plus 10 factorial upon 7 factorial and 3 factorial plus 10 factorial upon 9 factorial and 1 factorial equals to 2 to the power of n. Am I correct now? Okay, yes, after the live. Yes. So not only for this this video, for any video you can put it. You can send your comments. So that means we have basically some note. Please all of you note down. N factorial by r factorial into n minus r factorial is equal to NCR. This is the formula. So with the help of this we can write 10C1. 10C1 is 10 factorial by 1 factorial into 10 minus 1 is 9 factorial. This is 10C3 plus this is 10C5 plus 10C7, 10C9 equals to 2 to the power of n. This seems to be rather like this form. This seems to be NC1 plus NC3 plus NC5 and so on dash dash equals to. This is the sum of the odd powers of x. Sum of the odd powers of x, which equals to 2 to the power of actually n minus 1. But here n stands for 10. Therefore 2 to the power of n equals to 2 to the power of 10 minus 1. 2 to the power of 9. So n must be equal to 9. This is the answer. So that means fourth option is the right option. Yes, yes, yes. Now you cannot. After the completion of the session, it takes at least 15 to 20 minutes. Morning class 9:30. Today Narla is not there. Okay. 96th problem. 96th problem. When 2 to the power of 60 is divided by 49, the remainder left is. So if 2 to the power of 60 is divided by 49, what will be its remainder? We need to find out. Okay. First option 1, second option 44, third option 43, fourth option 28. Now 2 to the power of 60 is divided by the 49. The remainder left we need to find out. First consider 2 to the power of 60. This I will write like this. 2 cube whole to the power of 20. Can I write like this? 3 into 20, 60. Next 2 cube is 8. 8 to the power of 20. 8 I will write 1 plus 7 whole to the power of 20. This is 1 plus x to the power of n. This can be expanded like this. 1 plus 7c1, 7c1. Next we can write this will be 1 7c7, 7 to the power of 6, 7c2, 7 to the power of 7 to the power of 1, 7 square, 7c3, 7 cube, and so on. 7 to the power of 20 we can write. 7 to the power of 20 we can write. Okay, now this can be written 1 plus this is 7 into 7 is actually we have 49. 7c1 is 7, 49 plus 7c2 into 49 plus 7c3 into 49 into 7 plus dash dash 49 into 7 power 18 you can write. That means you can take out 49, 49, 49, 49 common. So that means we get like this: 49 common. You have 1 plus 7c2 plus 7c3 times 7 plus so on dash dash 7 to the power of 18 plus 1. Now you can say this is equal to something integer k, 49k plus 1. If you divide by 49, it leaves a remainder 1. So option is 1. Option is 1. Sorry, power is 20. Okay. Power is 20. Sorry. Absolutely sorry. I did mistake. Absolutely correct. Wait. Absolutely sorry. Please. Sorry for the inconvenience. Okay, now I will do it. Yes, n is equal to 20. Correct. You are correct. But you are good observers. Nice observation. So 1 plus 20c1 is 7 plus 20c2 7 square plus 20c3 7 cube so on dash dash plus 7 to the power of 20. Now you need to write 1 plus 20c1 is 20 is 140 plus here you can take 49 common, you get 20c2 plus 20c3 7 square and so on. Let us say this bracket is equal to something k. This will be like this now, 49k plus 141, you will get it now. You need to divide now. This 141 divided by, because this 49k is exactly divisible by 49. Divide what we need to write means, actually here remainder is equal to, in the previous case already we have done, fractional part of 141 divided by 49. So now divide 141 by 49, whatever remainder that you need to write. So, sorry, not fractional part, integral part you need to write. Integral part, or you need to check. Remainder only. So just you find like this. 49 2 ja 98, 3 ja 27, yes 2 ja 98. You will be getting how much actually here? 3 for 43. You will get 43. Remainder is 43. That means third option is the right option, not first option. First option is 1. So option 3 is the right option. See, you need to divide this one 49k plus 141 by 49. That means 49k by 49 is k. Okay, it's over. Now 141 by 9, it's a remainder you need to write. Remainder of this one. Remainder. So that remainder is actually 43. So answer is 43. That is option 3 is the right option. So thank you. The binomial theorem has been completed. Tomorrow which chapter shall I start? Tomorrow which chapter shall I start? That I will, now only I will give the notification. Come on, your choice. Your choice. Not 97 question over, completed. It's enough. Conics, okay, parabola. Morning parabola. Okay, morning parabola. Okay. Last permutation combinations followed by the probability. That I will do it. Areas evening. Areas in the evening. Right, thank you. Now I will check Prithvi. You may call to me also, no problem.